video cast is about how to write net ionic equations. If you have a job, you know that you have two types of pay, your gross pay and your net pay. The net pay is the one that is smaller. It's actually what you get to take home. Gross is what you make, and then what you get to take home is your net pay. So that's after they've taken out taxes and things like that. Well, when we have a net ionic equation, it takes out the things that aren't the species, the ions that aren't doing anything in the reaction, and really just boils down a reaction to exactly what is doing something in this particular reaction. So, net ionic reactions, I'm going to run through a list of how-tos, and then I'm going to show you how to work these. So, step one is to write down the reactants. You need to write those down with the correct formulas. Use your charges and crisscross. Then, predict the products based on the type of reaction. Most of the ones we're going to look at here in this section will be double replacement reactions. And we have a strategy for how to predict those products. If it were a single replacement reaction, we want to consult the activity series to make sure that reaction actually happens. And then, of course, because it is your obsession, you must balance that equation. Step 3 is we're going to use the solubility rules that are given to us to identify any insoluble compounds. We're going to identify them by underlining. What that means is those compounds those ions are too strongly attracted to each other for water to get in between them. So they are insoluble, they form a solid, and sink to the bottom of the beaker and will not split into their ions. Step 4, we write the overall ionic equation by splitting the substances that are soluble into ions. You do not want to split the insoluble compounds, and you'll have those underlined. So don't split the ones that you have underlined. We started doing this the other day, and I'm just going to kind of run through just to show you what I'm talking about. I'm just going to modify it a little bit. When we were talking about how ions split up, and we were looking at dissociation reactions. So if we took sodium chloride and split it up, and we put it in water, water gets in between the ions and separates them. So you get sodium ions and chloride ions floating around. We also did this with calcium chloride. And when you put polar water in there with its charged ends, it gets in between the ions. So you get calcium ions and you have chloride ions. But it actually forms 2 chloride ions, and we balance that way. The way we're going to modify this for our net ionic equations, instead of writing it like this, we're going to modify it a little bit, and we'll see calcium chloride written in the reaction. And underneath, we're going to write this part right here. So it splits into calcium ions, and so we have a plus sign in between the ions, chloride ions, and then you balance as you go. How many chloride ions? 2. All right. So that's what I mean by splitting the substances that are soluble into ions, and that's what it's going to look like. All right. Step number 5 is my favorite step. You're going to cross out the ions that are the same on both sides. These are the ions that aren't doing anything, so we call them spectator ions. They're floating around in solution at the beginning, and they're floating around in solution at the end, and just kind of watching the reaction happen. And the easiest step of all is step number 6, rewrite all the substances that are not crossed out, and that is your net ionic equation. So we're going to look at an equation, and I'm going to work one for you, and I'll go through these 6 steps. So we have a reaction, aqueous solution of sodium sulfide and iron 2 nitrate. So we need to write that with the correct formulas. So sodium sulfide means it's sulfur, so that would be Na2S, and we're going to react that with iron 2 nitrate. That Roman numeral 2 means that it is Fe2+, and nitrate is NO3 negative. All right, now this looks like it's going to be a double replacement reaction, and it is. Our strategy for doing that is we take our first things, our first ions or metals here, and write them up above the line that we're working with. Now, 2 positive ions are not going to want to bond together because there is no attraction there. There's actually more repulsion. So now they're just going to switch partners. Sodium's no longer going to be bonded to sulfur. It's going to be bonded to nitrate. And iron is no longer going to be bonded to nitrate, it's going to be bonded to sulfur. Some of the oxidation numbers here is 0, so I just end up with NaNO3. And then the same thing happens over here. Some of the oxidation numbers is 0, so don't have to add any extra subscripts. Of course, the next thing you should feel the need to do is balance, and so we will. All right, so we're up to step number 3. We're going to identify our insoluble compound. I said in here that these reactants are in aqueous solution, so we don't have to worry about them being insoluble because they obviously are. So we only have to worry about the products here at this level. So we look up each of these. So nitrates, all nitrates are soluble and there are no exceptions. Plus anything bonded to something in group 1, which sodium is always soluble. This is something you would never underline. It is going to split into its ions every single time. Now we look up the last thing here in our solubility rules. So sulfides, since it is just sulfur. And all sulfides are insoluble. There are some exceptions, but iron is not one of those. So this is my solid. We're going to underline it. It sinks to the bottom of the beaker and stays bound up. Now I'm going to go to step number 4. And I'm going to take each piece here. I'm going to start with just this one. And I'm going to split it into its ions. So Na2S is made up of sodium ions and sulfur ions. And then I need to balance as I go. So how many sodiums? 2. Now I'm going to pull down my plus sign, and I'm only going to work with this guy right here. And I'm using the red lines just to make it a little more apparent on this video cast. And I'm just going to work here with the iron nitrate. It is made up of iron 2 ions and nitrate ions. So it's really easy if you did this step right here. And then I need to balance as we go. How many nitrates? 2. Then, bring that arrow down. I'm going to work here with sodium nitrate. It splits up into sodium ions and nitrate ions. But because I have 2 of this whole thing splitting up, I get 2 of each of those ions. Bring down the plus sign, and the one that I underline, that you underline, do not split up. It's sitting at the bottom of the beaker. Water cannot get in between them. They will stay bonded to each other. Now we're at step number 5, where we need to get rid of our spectator ions. So they're going to appear the same on both sides. So one of those is sodium, and the other one is nitrate. You will notice that they are the ions that are involved in our soluble product. Those always end up being your spectator ions. All right. Now, all I have to do for step number 6 and to finish this problem is to rewrite everything that's not crossed off. So S2 negative, Fe2 plus, yield FeS. This is the only thing that's really happening here in this reaction, and that is your net ionic equation. You will have ions over here on the reactant side, and then on the other side you will have your precipitate.